NASA has been sending telescopes into orbit for decades, but none have come close to the James Webb Space Telescope. Despite the high cost and lengthy delays, no other observation station has been met with such high expectations as the JWST. The new powerful telescope, on the other hand, is already demonstrating its worth with a terrifying revelation about the warp bubble that changes everything. What exactly is a warp bubble? What has the JWST discovered? But more importantly, should you be scared? There are many fascinating places to explore in the vastness of space. There are countless exoplanets, galaxies, black holes, and other objects in the universe. Humans are an inquiring race who seek to learn about their surroundings, both nearby and far away. We are eager to find exactly what is out there. Do our cosmic neighbors have intelligences comparable to or higher than ours? Is there an exoplanet out there that supports life in any form? However, distance is a barrier to space travel because the cosmos is so vast. Given the vastness of the universe, the red planet is relatively close to us. However, volunteers for Elon Musk's colonization endeavor must endure more than 5 months of traveling through the hostile atmosphere of deep space before arriving on their new home world. But what if you want to visit Proxima b, the closest exoplanet to Earth, using modern technology? That's a pipe dream. The exoplanet is located 4.24 light years away from Earth. A light year is 5.88 trillion miles, hence the nearest exoplanet is around 25 trillion miles away at 4.24 light years. That is simply not possible. However, this will not dampen our spirit of discovery, as we have discovered ways to reach distant celestial objects, the telescopes in space. If we can't get to these objects, we can send out powerful eyes to study them and expose their secrets from a distance. NASA has a long history of sending telescopes into space. One of the most celebrated telescopes in space is the Hubble, which orbits the Earth from where scientists train it on different parts of the universe. However, NASA is the type of agency that simply can't stop launching satellites and finding uses for them in relation to the warp drive. There is a new eye in space that outperforms everything humans have deployed to observe objects far from us in the universe. That is the James Webb Space Telescope, which replaces the Hubble as the most powerful space telescope. Thanks to the JWST, scientists can now see further back in time to study how stars were formed close to the event that created the universe. It is 100 times more powerful than the Hubble and can now see farther into the history of the universe than the weakened star, which is within 350 million years of the Big Bang. If you're wondering how the JWST can look back billions of years, it's because light from distant stars is only now reaching us after traveling for billions of years. This light will show us what the stars were like billions of years ago from trillions of miles distant, despite the fact that some of them may have died. NASA has issued the list of the first set of images that will be used to demonstrate the capabilities of the JWST. It includes the Carina Nebulae, a pair of nebulae and luminous zones in interstellar space. It is a billowy cloud of gas and dust roughly 7,600 light years from Earth that is home to several bright stars many times the size of our Sun. The images will also include the Stevens Quintet, a galaxy cluster located approximately 1 million light years away. This galaxy group is remarkable because 4 of the 5 galaxies are locked in a type of dance with each other, their shapes twisted by each other's gravitational forces. We will witness magnificent images of another galaxy cluster, SMACS 0723. What makes this cluster unique is that the galaxies distort and magnify the light from other objects behind them. This feature enables telescopes to detect very distant and weak galaxies further away. In fact, it is in this type of situation where the JWST shines best. Few discoveries made by the JWST, however, will come close to the warp bubble because it will change everything. Let us begin with what a warp bubble is. This is a fairly complicated subject that requires a lot of math knowledge for a detailed understanding, but we will make do with a basic definition. A warp bubble is a bit of space that is contracted in the front and expanded in the back, theoretically pushing the bubble and its contents forward at speeds exceeding the speed of light without ever violating the laws of physics, because when you travel in a warp bubble, you are not technically traveling faster than light. You are simply surfing a bubble of condensed space. What's the big deal about warp bubbles? because they eliminate a significant issue with faster than light travel time dilation. What exactly does this mean? Assume that you were able to travel faster than the speed of light. Everything outside of your craft would accelerate, which means that the 3-hour excursion you took to a pleasant tropical planet could have equated to years on Earth. Simply put, if you want to travel faster than light while sticking to known physical laws, you should say goodbye to everything you've ever loved before setting out. However, warp bubbles avoid this issue because the space inside the bubble remains unchanged. Therefore, an hour spent traveling at warp speed means that just an hour passes for everyone else who is not now in your warp bubble. Fans of the Star Trek franchise are familiar with warp travel. The warp drive is a wonderful futuristic technology from the Star Trek universe, which has included 10 television series and 13 feature films since the first episode in 1966. Characters in the series explore the universe in powerful and fast spaceships, moving from planet to planet and communicating with an extraterrestrial crew. The torsion engine is the main attraction, since the story would be implausible without it. The universe is bizarre, incomprehensible, and ridiculously vast, and even if you wish to visit the next star, the vast cosmic distances create an almost impossible barrier. Let's look at the next star, Proxima Centauri, which is 4.5 light-years distant. If you could travel at the speed of light, it would take you 4.5 years to reach the star. Light travels at full cosmic speed and functions as a type of universal speed limiter, so any other way takes longer. Even with the fastest space probe built, the long journey into the interstellar abyss would take about 8,000 years, thus staying close to Earth and its nearby environment makes sense. Of course, the Star Trek crew didn't stay close to Earth because they discovered a solution that allows long-distance travel by shortening the time it takes to travel. The torsion engine, which uses warp drive technology, accomplishes this by juggling space and time, making for excellent entertainment. Warp drive was destined to remain a fantasy until, at the close of the past century, a scientist suddenly realized that such an engine was actually possible. What are the real-world consequences of warp bubbles? Let's look at the nearest star to Earth, Proxima Centauri, which is around 4.25 light-years away, or about 25 trillion miles, or 40 trillion kilometers. The Parker Solar Probe will be the fastest spacecraft ever, reaching a top speed of 450,000 miles per hour. This is very fast because it will only take you 20 seconds to travel from Los Angeles to New York City at that speed. But if you travel to Proxima Centauri at that speed, it will take you approximately 6,663 years to arrive. However, using warp bubbles, you can theoretically travel to Alpha Centauri in a month, as measured by clocks on the spacecraft and clocks in mission control. The physicist was Miguel Alcubierre, and he came up with a theory that rocked the scientific community worldwide in 1994. Alcubierre was doing his PhD research on Einstein's general theory of relativity when he saw an episode of Next Generation where heavy masses can curve space and time. So Alcubierre picked up a scrap of paper, did the calculations, and laid the foundation for an article that appeared in the Science magazine later that year. In his paper, Alcubierre describes how to compress space and time in front of a spacecraft and stretch it back behind the ship to travel a much shorter distance to the desired destination, safely trapped in what he calls a torsion bubble in visualization. However, there is a problem with Alcubierre's warp bubble. You see, the warp engine is difficult to make in reality. You can't just aggressively curve space with normal mass. You need exotic matter with negative gravity. Alcubierre's warp drive would function by enclosing the spaceship in a bubble of flat space-time and twisting space-time around that bubble to shorten distances. To work, a warp drive would need either negative mass, a theorized type of matter, or a ring of negative energy density. But because physicists have never observed negative mass, we are left with negative energy as the only option. To generate negative energy, a warp drive would require a massive amount of mass to create an imbalance between particles and antiparticles. For example, if an electron and an anti-electron appear near the warp drive, one of the particles will be trapped by the mass, resulting in an imbalance. This imbalance results in negative energy density. Alcubierre's warp drive would use this negative energy to create the space-time bubble. However, in order for a warp drive to generate enough negative energy, a large amount of matter would be required. Alcubierre estimated that a warp drive with a 100 meter would require the mass of the entire visible universe. This appears to be a no-go zone. Warp bubbles appear to be a concept that will never be realized in real life. But a completely coincidental discovery is reigniting interest in the concept and could prove to be a breakthrough. But for fans of the warp drive, there is another source of hope of seeing a real warp drive built. And in the traditional method of discovering things, the way to construct a working warp drive may have been discovered by accident. Harold White is a researcher working on a special project funded by DARPA, the Defense Advanced Research Projects Agency. He and his colleagues published their work at the Eagle Works Laboratory in Texas on the potential structure of the energy contained in a Casimir cavity. According to the report, White and his colleagues discovered a micro-nanoscale system that can predict the distribution of negative energy density, which looked exactly like what the Alcubierre needed to work. To put it another way, White and his colleagues were investigating the idea put out by Dutch physicist Hendrik Casimir about how energy is distributed among wavelengths when they unintentionally conducted a microscopic experiment. White explained that careful numerical analysis of the team's custom Casimir cavities helped them identify a real manufacturable nanomicrostructure that is predicted to generate a negative vacuum energy density so that it would manifest a real nanoscale warp bubble, not an analog. Still, the real thing, meaning a warp bubble structure, will manifest. The experiment produced enough theoretical energy to achieve the warp speed concept theorized by Alcubierre. White was also aware of Alcubierre's theoretically sound proposal for a warp drive that can go faster than the speed of light without breaking acknowledged rules of physics. However, he was also aware of how the proposal had been mocked for relying on theoretical materials and enormous amounts of energy that were nearly impossible to design in any useful form. Alcubierre's original metric was revised by White and transformed into a canonical form which significantly decreased the need for unusual materials and energy in the original design. The updated concept led to the informal renaming of the original theoretical design, which is now more popularly known as the Alcubierre-White warp drive. It also gave researchers and science fiction lovers alike at least a glimpse of optimism that a real-world warp drive may one day become a reality. White thinks it will only be a matter of time before he or another researcher designs and tests his mini warp craft. White cautions that this does not mean we are close to creating a fully operational warp drive, since much more science needs to be done. However, there is at least a glimmer of hope that humans one day could be zipping all over the galaxy in a Star Trek-inspired warp bubble. What do you think about warp bubbles? Let us know in the comments section below.